Hello, welcome back. This is our video solution for problem 2 from quiz 2. So we're given a function which is similar to the problem from function 1, only the natural log has magically disappeared. And we're asked to find the range of this function. So remember, the range is all of the actual outputs that you get, no matter what x and y you put in. Now, in the problem 1, we were able to find out that the domain for this function was going to be the right half of a circle with radius 2. And well, before we had a natural log in it, which made it so you didn't include the y-axis, but that's not an issue here. So let's quickly sketch the domain of this function. So we're going to draw at least the right half of a circle with radius 2. And the domain is going to be everything. Well, okay, we get actually when x is 0, that's okay, except when y is 0, right? We can't have that. So there's like a little hole, a little hole around the origin. Okay, fine. So you get everything down this axis here, and then you get everything inside this circle with radius 2. Okay, so that's the domain, right? So this tells you that your inputs, right, here are all going to live, well, the x's have to live between 0 and 2. The y's can go between -2 and 2, except you can't make x and y both equal to 0. Okay, fine. But we want, when we put any of these green points into the function, we want to know what is going to come out. Now, it's useful to remember, right, if we forget about the 1 over, if we just looked at this function, z equals root 4 minus x squared minus y squared, and we squared it, okay, so I'm going to square this, then I get z squared equals 4 minus x squared minus y squared. Or, equivalently, x squared plus y squared plus z squared is equal to 4. Okay, so here I just added x squared and y squared to both sides. And this here is the equation of a sphere with radius 2. Okay, so if we are graphing that thing, right? Oops. All right, I'm getting the top half of a sphere, where here the radius of that sphere is equal to 2. Okay, well, because the radius is 2, that means I'm not going to go up past 2 height. Right? Okay, in fact, where would I get that max 2 height? Well, that would occur at the origin, right, where x and y are both 0. But that's actually not going to be in my domain, so I really can't actually get this max height. There's actually a big hole up here at the top. Okay. Cool, so how am I going to get, by the way, the 0 at the bottom? Well, actually, I can't do that either. If I get an output of 0, then I'm actually going to be taking the square root of 0, which is 0, and then I'm doing 1 over 0. So that's no good either. So actually, we don't get anything at the bottom. So what we know is that this quantity, this square root, in our domain is going to be between 0 and 2. And so if we invert, so we're going to invert, well, inverting is going to switch the direction of the inequalities. So first I'll get 1/2 is less than, and then I invert root 1 over root 4 minus x squared minus y squared, less than, well, inverting 0 in this case means we're going to go to infinity, right? Because we're going from the positive direction. All right, so we know that for values of x and y in our domain, this function 1 over root 4 minus x squared minus y squared is going to hit every value between 1/2 and infinity. And so this is our range.